Hello, sixth grade. Um, just um, all right. So this is page 100 to 107 in your health book. We've been talking about your cerebrum and your brain, and your cerebrum is the largest part. But if you look on page 98, you'll see your cerebellum kind of comes up underneath, in the back, but kind of up underneath there. And that's the second largest part, and it is responsible for balance and coordination. So if you think of your cerebrum, then and that was thought and memory, like thinking processes. Your cerebellum is like your actions, how coordinated you are, how athletic you may be. It's also sends messages to your cerebrum as well. Anyways, that cerebellum is just to kind of coordinate all of your movements and that kind of thing. Then you've got your spinal cord, and that comes, or well, first, I'm sorry, your brainstem. Your brainstem's kind of at the base there, and it is responsible for all of your involuntary actions. Okay, so blinking, your heart rate, breathing, your digestion, your um, swallowing. Just there's way more than you realize. Even like sweating and um, oil glands and those kinds of things all have to do with that autonomic or that automatic nervous system, and that has to do with your brainstem. Your brainstem does that there. All right, your spinal cord is a bundle of nerves, like literally all your nerves kind of merge into your spinal cord, and then it all kind of comes up and down your spine, your back. And of course, it's covered with your vertebra. It carries messages between your nerves all through your body to your brain, and then sometimes back to your body, depending on what the need is there. Sometimes a message is going to travel just to the spinal cord, and without even carrying the message to your brain, it knows what to do and it tells your body to do it. So if you stick your hand on a hot stove, immediately those nerves, they send, okay, second. All right, so your nerves, if you put your hand on that hot stove, your nerve is going to tell your spinal cord that you're touching something hot, and then your spinal cord is going to tell your muscles to pull that hand away, and all of that happens within a split second. And so those are called reflex actions, and your spinal cord takes care of all those reflex actions. Remember, your brain and your spinal cord, that is your central nervous system, and all of your nerves that kind of come towards it, that is your peripheral nervous system there. And you've got 102 there. Your peripheral nervous system, your nerves, your spinal. You have spinal nerves that come from your spine, and cranial nerves that come from your cranium or your head, basically area there comes out there. And then we talked about your brain stem. You have sensory nerve fibers. Basically, that's what you're sensing. That your senses all have to do with your sensory nerve fibers. You have temperature receptors, you have pain receptors, pressure receptors, all throughout your body, and so you can tell. Is it cold in here? Is that hot? Is it uncomfortable? All of those things. Is that too much pressure on your body? Is that pain? Whatever it is, it's telling your body or your brain continually what's going on around you. And that's all through your sensory nerve fibers and your senses. Then you have motor nerve fibers. You'll see on page 104. Your brain and spinal cord send orders for action through these nerve fibers. And it's your sensory nerve fibers are bringing it to your brain, and your motor nerve fibers are taking it away from your brain and telling your body what to do. So whenever you were little, maybe you've seen little babies like try to pick up a green bean, and they pick up the green bean, and by the time they get it to their mouth, they go, whoop, and it pops out and they can't get it in there. It's because they're developing their motor skills, they're developing their movement, and they haven't quite developed it just yet. And it's really fun to watch a newborn, or not a newborn, but a baby learn how to feed themselves or to pick up something like that. That's really interesting to me, anyway, to see them do that. So you've got your, like I said, your sense of touch. You've got all of the sensory receptors in there, pain, pressure, temperature receptors going on all throughout your body. Then you have a sense of smell over on page 105. And, smells they can be wonderful. When you walk in your house and, mom's baked cookies and you're like, those are my favorite cookies. Or you could walk in and like maybe you forgot to take out the trash and you're like, oh, what is that smell? And so it can warn you of danger. Maybe you come up the steps and you're like, what is it? Smoke? It smells like smoke. It might warn you of danger. And so it just depends on what you're smelling. But these are all types of sensory receptors. And the type of receptors that are in your nose are called olfactory, O-L and then factory, not olfactory. However, that's how I remember it, is if you walked into an old factory, it would smell bad, right? That would probably be the first thing you would notice. And so I think of the olfactory enhancing your olfactory nerves or your olfactory receptors. And that's how I remember the olfactory stuff goes with the nose. Remember that. All right, and then you also have your taste buds, and of course, you have lots of different types of taste buds. You have salty, sweet, bitter, what they call umami. What am I missing? Salty, sour ones. I'm not a big fan of that, but some of y'all may love Sour Patch and that kind of thing, and that's like your thing. I'm probably like the salty and sweet. But anyway, they're all located on the different parts of your tongue. You've been taught that before. The bitter's more on the back, the sweet's more on the tip, the sour's on the sides, and so on and so forth. And so, what they say umami is like savory, like when you think of meat or something along those lines. It like is tickling, or I want to use the word enhancing. That's not right. It's making all of your taste buds work, or it's why can I not think of that word? It's causing all of your taste buds to react. Okay, that's kind of the idea that I'm thinking there. A great fun experiment that we've done in class before. You could do it with your little brother or sister. No, don't do that. Where you blindfold yourself, not your little brother or sister, and you have them take a bite of an apple, and then tell them, okay, now taste this, and you can take a bite of an onion. Yeah, they can tell the difference, right? Or sometimes different types of food, you can like put little drops of things like lemon juice or sugar water or salt water or something like that, and see how it tastes. But the cool thing is if you put salt on the tip of your tongue, see how long it takes to taste it. Or if you put something bitter on the tip of your tongue, or maybe you put something sweet on the back or the side of your tongue. That's kind of a fun little experiment to try as well. And then you will also be able, let's see here, is this 107? So I'll stop here. All right, so anyways, you can definitely see how all of these tastes and all of these types of things, your taste buds and then your olfactory receptors and all that all is sending it to your brain, and then your brain's telling you what, if you like it or you don't like it, or if it's, dangerous or whatever. Something that's really interesting to me, and it's just for free, but if how you walk into a room and let's say it smells really bad or pungent, that means like vinegary or strong. Let's say you walk into the room and you smell that, or you smell something, like really perfumey, and you stay in there for, maybe a few minutes and you're like, well, I don't even smell anymore. and then somebody new comes in, they're like, whoo, what is that smell? And then you're like, oh, I forgot about it. It doesn't even smell. Well, what happens is your olfactory receptors will only continually tell your brain that for so long. And then it's like, okay, I've already sent the message to your brain. You know it stinks. Now I'm going to stop sending that message to your brain. So the smell is still there, but it's the nerve endings and the receptors stop sending, those olfactory nerves stop sending the messages to your brain, and your brain can kind of compensate for that to where you can handle and you get used to the smell. So that's just for free. All right. Have a good day.